name is Om Makwana. My student ID is 1014144422. I'm going to explain you the assignment 2 which I have done in this. So first of all, we have imported the dataset into location of the assignment folder below our Python file. After uploading the CSV file into the data file, we mounted it over here. Let me run this. All right, already mounted because I already mounted it. Then we'll also find this. We'll save it in the variable called file name, which is assignment to iris.csv. After that, we will import the pandas as PD, and then first we will show the first row of the data frames. So as you can see, this is the first row of the data frame. Okay. In the second, convert the last column string to integer as a Setosa 0, Vesicolor 0, 1, and Virginica 2. Then once you run it, it will convert it. As you can see, this is the output from which we can having the Vesicolor 1 and Virginica 2. Okay, so let's go to the question 2b. Now check the first 5 element of iris data once again. As you can see, this is the iris data. Let's go forward to the next question, which is select the first 4 column of the data frame as the data and call the data x. So this is the x, we have valuing the first 4 column. After that, this is the y, which is the last column, and then when we print it, we can see the data. All right, now it's time to split the data x and the label y into training and testing segment. Okay, we will split the data and label into training and testing segment while size of the data is 20%, and use the random 1 2 3 or make it all the answers similar in the whole class. Okay, so let me just run this. So again, we'll check the top 5. I already run the outputs to double check everything, so you might be seeing the same output. So this is the top 5 row of the x test, that was the train and test. Now we'll go with the y train and then the y test. Okay, so now we'll check the length of the x train and x test. If the number are like 120 and 30, then we are good, otherwise we have to work on that. So now we'll convert the y train and y test from category to one hot encoded values and call them into one hot trail labels. All right, so first we'll just process the label encoder and TensorFlow keras. So let me just run it. So it will print the first 5 rows of the hot train label, and then it will test it and it will show the test result. All right, so let's move to the sixth question, which is define a substantial model containing thin dense layer. So as you can see, these are 3 dense layers. Okay, in the first and second layer, use 100 as we have used 100 as a hidden unit and a relo as an activation function. Okay, so and the reason is we have 3 classes: Sentosa, Versicolor, and Virginica, which is to also pick an appropriate loss function for the last layer. Okay, so we'll just run this and we'll able to see the data, which is this. As you can see, we have taken the hidden units, which is 100. We also got it 100, and then 3 for the activation function, which is softmax. Okay, so let's move on to the B part, which is now we'll just compile the model using the RMPROP optimizer. So let me just compile, and then now we'll train our model using the epoch as 20 and batch size as 10. So this is all the training of the model. So now we'll see the accuracy, and then once we see the accuracy, we'll able to identify the how's the accuracy of the function that we have created. So it's basically 0.900. That is good. So we'll move forward to the 9th question A. Now we repeat all we have done in the 6 in the following parameters. In the first, second hidden layers, use 10 hidden layer neurons as a relay activation function. All right, so let me just run it. What we have done is basically doing the same thing. We just change the hidden layers 100 to 10 and then reload as activation format. So this is the output from this changes. Okay, now use the same setting as for the 6th B. Compile using optimizer loss function and output the accuracy. We'll just compile the thing and then we'll just train the data. All right, after that, calculate the result evaluating the x test and one hot test label and report the accuracy of your model. Yeah, so we'll just basically testing and doing the accuracy of the model. So this is the accuracy of the model. Now let's move on to the question 10. It's basically more theoretical questions. So first question is how the number of layers of our hidden units could impact the accuracy of model. So basically, more layers and hidden units can capture more complex pattern, potentially increases accuracy, but too many can lead to overfitting, especially with small data set, I guess. So let's move to the second question, which is, do we always suffer from overfitting? Well, it depends. Like, we don't always suffer from overfitting. Overfitting occurs when the model learns the training data too well, including noise. It's more common with complex models and small data sets. Okay, so third question is how we can detect overfitting. For detecting, we should compare the training and validation accuracy loss. So if the training accuracy continues to improve while validating accuracy decreases, it's likely overfitting. So what's the fourth question? How we can reduce overfitting? Okay, so first, to do the reduce overfitting, we should try the technique which is regularization, which is L1, L2, and dropout. Increasing the training data reduce model complexity. Fewer layers might help, and then early stopping might be also an option. All right, so let's go to the question 10b. So use different setting than the ones we choose in 9. Okay, change each of the following. First one is optimizer. So let's go to the question 6b, which which is over here. So what we have to do is like just optimizer. Okay, we'll just change the optimizer. So our optimizer is RMS prop. We'll just change it to Adam. All right, so let me just run it. All right, so we just basically change the optimizer like Adam, so may converge faster or find better minima than simpler optimizer like SGD. Yeah, so let's go to the second question, which is number of layers. So we'll just change the number of layers. Okay, just a second. Number of layers. So what we'll do is we'll just add one layer which is like this, and then we'll include it inside of this. Just we'll use 10, and then we'll use the activation as a ReLU. So basically we are adding the another layer to this. So as you can see, we have added this one layer. Now why we added is because like more layers allow the network to learn more complex patterns, but as I said earlier, too many layers can cause the model to memorize training data rather than generalize. Okay, so optimizer is done, number of layers is done. Now let's go with the hidden units. Okay, so we just changed the hidden units in the question 6. Where it is? Yeah, here it is. So we'll just change the unit of 100 to 10. It's the same thing which we did in the question 9. So as you can see, by changing the changing the hidden unit, increasing hidden units can improve model capacity, but it may increase training time and overfitting risk. So more units allow the network to capture more feature, but can also lead to learning noises in the data, the things which I've earlier said. So now we'll just go with the number of epochs and batch size. So as you can see, in here there's a epoch is 20. Let me put it to the 10, and then batch size I'll put it to 20. Okay, let me just run it, and then we'll get to see some changes. So the changes we have is that basically longer training allows the model to learn more from data, but eventually it may start fitting to noise. All right, for the larger batch size can lead to faster training but may result in lower accuracy, and overfitting can be occur as well. All right, so these all are the questions which I have answered. So this was my assignment too. Thank you so much, sir, for the assignment, and there is much more we learned from this assignment. Thank you so much. Have a good day.